Hello everyone. So till now we have discussed the intro to stream, then how to create a stream, what are the intermediate operation a stream has, and also the terminal operation. Today I'll briefly talk about the parallel stream concept. It's a method, parallel stream, it's a method. So this method, okay, and it is used to process elements of a collection in parallel using multiple threads, and it uses fork join, and also it is part of stream API that is introduced in Java 8. When we can use parallel stream, so let's say we are processing a large collection, that time parallel stream can be used. And if the operations are CPU intensive, stateless and independent. So stateless means I have already mentioned earlier. So like filter, map, flat map, pick, all these operations are stateless. So whenever we are using this operation, we can use parallel streams, and also order if there is no order required. I mean, if order of output does not matter, in that case we can use parallel stream. So when we should not use parallel stream? When order of result is important, and like for small data set, we should not use parallel stream. So in that case, parallel overhead will be greater than gain, right? And if there is a thread safety issue, okay, if thread safety is an issue, then we should not use parallel stream. And for IO bound operation, we should not use parallel stream. So let me show you how what are the internal method that parallel stream uses. So if I click here, you can see a split iterator. So this is an interface that parallel stream uses. So in this split iterator, there is a method called try split. Okay. So what it does, it basically try to split the source into a smaller chunks. Each chunk is submitted to fork join pool as an independent task. Okay, and later each chunk is processed in a separate thread from fork join pool, and results are merged back together for terminal operation like collect, reduce. Okay, so let me show you this visualization. So how we can do it. So let's say we have these 8 elements, and so what it does, basically first it try to split in 2 halves, and then again each half is split into another 2 halves, and then another 2 halves. Like that it split until it reaches to a smallest element, and then it submit to fork join pool, and it like fork join pool, each thread will process each task and then merge it whenever we are calling, let's say, collect or reduce, all this operation we do. So at that time it merge. So that is the internal of parallel stream. So let me show you this example, how parallel stream make our operations faster. Okay, so if I run this program, so you can see here, so sequential processing is taking 5 milliseconds, where parallel processing is taking 2 milliseconds. So what it is doing, basically, first one, this is sequential one. So it is printing all the names that is present in this list. Okay, so first what we are doing, we are taking the time, and then after processing using the sequential string, we are calculating the time taken for this operation, and for parallel also same. So this is the difference. So for normal stream we use string, and for parallel stream we use parallel stream. And same here, I have taken the start time, and also after processing the time I have taken and deducted. So I got the total processing time. So in case of sequential processing, you can see it's 5 milliseconds. For parallel processing, it's 2 milliseconds. Parallel stream basically makes it faster. So it depends on CPU and also the task. If the task is more CPU bound, then our task will be faster, right? So that's it, what I wanted to discuss today. I hope you liked it. Please like the video, share it with your friends, and also do not forget to subscribe to my channel and click on the bell icon so that when I upload a new video in the next time,